Very good morning to all of you. Welcome you guys. Welcome you all. How you are doing everybody? कैसे हो सभी लोग? I hope all of you are doing great. A great news to all the aspirants of the prepare who are seriously preparing for 2027 2028 के लिए. So now this Unacademy subscription that is just 7,999 only. Yes, this is one of the greatest opportunities for the students who are seriously preparing for GATE 2027 के लिए. So utilize this opportunity before going to expire. So this offer which is going to end tonight only. Keep in mind. So great opportunity. So never miss this opportunity. Utilize this opportunity before it going to expire. So you will get the 6 months plus additionally 1 month benefit आपको मिलेगा. So use the code of BV Reddy, my personalized invite code BV Reddy, and to have the great learning experience from the top educators team. So this is the last live batch you can have a look at now. For 2027 के लिए the top educators of an academy you can find एक साथ आपको मिलेगा. We are starting a new batches. We are starting from 24th से नया batch शुरू हुआ. 90% of scholarship. And so there is a scholarship test on 26th July. 2 sessions. One is at 11 a.m. The other one is at 5 p.m. Do enroll immediately. And so this is the last live batch for 2027 के लिए. We are starting new subject control systems, and I'm starting with the networks. I'm starting. Yes, don't miss this opportunity. Utilize this one before going to expire. For 2028 के लिए भी नया बैच शुरू हो गया for GATE and ESC के लिए. And use the code of BV Reddy. Right. These are the Unacademy top rankers of 2026. You can have a look at now here. All these are the rankers from EC and electrical. You can see now how many rankers are there. And ESC 2025 ka rankers you can have a look at. Yes, there are so many rankers are there in all the branches. And what we offer, we do offer the 2 subscription and plus wala as well as the iconic. प्लस में आपको क्या चीज मिलेगा? द टॉप एडुकेटर्स क्लासेस मिलेगा, लाइव डाउट्स एंड अवेलेबल टेस्ट सीरीज, स्ट्रक्चर्ड कोर्सेस, लाइव क्विज, अनलिमिटेड एक्सेस. आइकॉनिक में और भी ज्यादा बेनिफिट मिलेगा, पर्सनल कोच भी मिलेगा एंड फिजिकल नोट्स आल्सो विल गेट. And you can start your serious preparation with an academy to achieve your dream goals. We are there to provide you the best guidance. Let's crack it. Yeah. चलिए आज का सेशन हम शुरू करेगा. Yes. Coming to this course now here. So here you will get to know all this. We are going to discuss the most important expected previous year all type of SSC question, JEE questions we are going to discuss. SSC, JEE, so all the state government exams का सारे के सारा solution आपको मिलेगा इधर. Do utilize this one before going to expire. Yes, all of you do join the live sessions to have the great learning experience. Take this problem. A series circuit has 3 ohms, 10 ohms, 20 ohms and 2 volts DC in series. If the 10 ohm resistor is replaced by open circuit, the current in the circuit is, yeah, what happened? You can pull your answer. You can pull your answer. Now what they given now here, initially the circuit contained what, tell me now, 3 ohm, 10 ohm and 20 ohms. And how these are connected, you can see now. Connected to DC, so this is 3 and this is 10 and this is 20 ohms. Now what they're saying here, 10 ohm resistor is replaced with the open circuit. That means this 10 ohm resistor is removed now. If the 10 ohm resistor is removed, then so how much the flow of current in the circuit now? This current is I. Then how much is value of I, you tell me now? 0. Right. The current is 0. There is no flow of current now, open circuit. No flow of current. Right. And these questions are the all the SSC, JEE and state government. So like we can say all type of questions CIL के लिए useful होगा, राजस्थान public sector के लिए भी use करेगा this thing. So we will discuss the complete all the networks, digital signals. So we will this control systems also will be covered in this continuously classes. Okay. So do join the classes. If you are joining regularly, we'll continuously will discuss the classes. Right. Next. And the level of the questions are all are SHG level questions only. Remember, this is very much helpful for your exams. All. So this is GenCo, Transco KB. This is very much helpful. For DC voltage, inductor behaves as. How the inductor will behave for DC voltage. Now, so we can see now the impedance of a inductor, which is equal to what, tell me now? J omega L. And omega equal to what, tell me now? 2 pi F into L. For DC, how much the frequency, you tell me now? Frequency 0. So that means ZL value will becomes what, tell me now? 0 now. So the impedance is 0. That means this is called as what, tell me now? Short circuit. Next, the ratio of resistance of 100 watts 220 volts lamp to that of 100 watts 110 volts ramp. So that means we have the two bulbs they given now. One bulb having this wattage. How much it is now here? 100 watts the power. We can say bulb 1, that is lamp 1 they are saying. This is a lamp 1. And the power which is given as what, you tell me now here? 100 watts. And then voltage which is given as how much now? 220. From this we can get the resistance now. From this we'll get the resistance. How much is the resistance? You can see now. How much is the resistance? You can see now here. R equal to V squared by P. So this means let us say R1. V squared means what, we can say 220 into 220 by P. P is value 100. 0, 0, 0, 0. So this value from this resistance value will come now here. I think 484. So this is the resistance value. Now let's talk about the second lamp now here. So that is lamp 2. So that means which is given as power P, which is given as 100 watts, voltage V, which is given as 110 volts. Now the resistance R2, which is given as what, V square by P. So this is R2 is V square So this means 110 into 110 by P. So this value 100 now. So will come to be a R2 value. Yes, so it will come to be a 2. How much this value? 11 square means 122 now. 121. Isn't it? 121 will come. Yeah, now we need to get the ratio between these two now. They are asking to find R1 by R2. How much now? 484 by 121, which will be equal to 4 by 1. Right. Next one. If four 10 microfarad capacitors are connected in parallel, the net capacitance is, how these are connected? They are saying now parallel now. Four capacitors are connected in parallel. Then equivalent capacitance will be given as what terminal here? C, all are connected in parallel. Then if I say A and B, the equivalent capacitance between A and B, and which is equal to what you tell me now here? 4 into C. So we'll commit as CAB value. How much now here? 40 microfarads. So option B. Next one. A wire has a resistance of 10 ohms. It is stretched by its 1/10 of its original length. Then its resistance is stretching. Whenever a wire is stretched, what is constant now? If the wire is stretched means volume remains constant, keep in mind. If the wire is stretched, its volume remains constant. Volume constant. So that means resistance of a material is given as R is equal to rho L by A. Now we are multiplying and dividing with L. So that is R is equal to rho into L squared by V. V is the volume. So you can see now stretching is done, and which is constant. You see this thing, rho is a constant. Why? Because rho is the resistivity, it belongs to material. So rho value constant and volume is also constant. From this we can say now this is R proportional to L square. So that means what we can write now here, R1 by R2, which will be equal to what L now? L1 by L2 whole square. Now see this thing, what they given now? Resistance, initially they given this as R1 value given as a 10. And we need to get this R2 value, we need to find. And what else now here? The length. If I say this as L1, if I call this as a 100 meters, then this L2 is what, tell me now? 1/10 of its original length. That means what, tell me now? 100 plus 10 na? So we'll come it as 110 meters. So we'll come it as R1 value, how much now? 10 by R2, which is equal to L1 is 100 by 110 whole square. So how much is value? 10 by R2, which will be equal to, this is 100 by 121. Now you can see now the 0 will get cancelled. So finally this R2 value is what, tell me now? 12.1 ohms. Okay. Next one. Two incandescent bulbs of rating 230, 100 watts. 230, 500 watts are connected in parallel across the mains. As a result, what will happen? They are asking the which one will glows brighter. Which one will glows brighter? So here you can see the two bulbs we have. Bulb 1. Bulb 1, they given this voltage which is given as a 230 and this power which is given as 100 watts. Next, now we can say now this resistance, if I call this is which is given as what element now? V square by P. So how much will be the resistance? Now you can see now this is R1 V square means 230 into 230 by P. P value how much now? 100. 230 into 2. So then this value how much will come? This R1 value, tell me now. 23 square. So this is 529 ohms. Next, this is the resistance of first bulb. Similarly, we can find the resistance of the second bulb now. That is also V square by P only na. V square. So this is 23 square, 23, 20, 230, 230 into P value 500. So that means how much will come? This is 529 by 5 na. This resistance is 105. So R2 value we can say nearly 106 ohms. Right. Now these two are bulbs are connected in parallel, they connected. How these two bulbs connected in parallel? Right. So this is B1 and this is B2. These two are connected in parallel to the mains. So the voltage to same aina, and we'll talk about the powers now here. Power P, which is equal to what you tell me now, V square by R. Now this power which is inversely proportional to resistance, right? Whichever having the high resistance will have a low power. Now here you can see now here this is R1 is greater than R2. That's why what I can say now, P1 is less than P2. P1 is less than P2. So that means whose power is more? You tell me now. 500 watt bulb will glow brighter, isn't it? Next one. In a balanced star network, the measured resistance between any two terminals is 6. The resistance between any two of the equivalent delta network is balanced star network. Now they are asking to find the resistance between any two terminals of the delta network is. Balanced star network means all the resistance are equal first of all. So they are saying it as a, this is the star network. Okay, if I call this point is A and this point is B and this point is C. Okay. Now if I call this resistance is RA, if I call this as R, this also R, this also R only. Balanced network now. Now all are same only. So tell me now here, the resistance between any two terminals is given as 6. That means the resistance between A and B. So that means they given RAB. RAB, they given us how much now? 6 ohms. Okay, that means R. 2R is equal to 6. That means R value is equal to 3 ohms. Now they ask us to find the resistance between any two terminals of the delta network. Now we got all the values. We got now corresponding delta network we need to get. So delta network by joining these two now. So here we'll get the delta part will come now. If I call this is my R1, tell me the R1 formula, which will be equal to, that is the resistance 3 plus 3 plus 3 into 3 by 3 na, 3 get cancelled. So that means R1 value how much now? 9. All are 999 only, isn't it? 9 option. Next, Kirchhoff current law is based upon Kirchhoff current law, that is a KCL. KCL is based upon what, tell me now? That is a law of conservation of charges. Law of conservation of charges. KCL is law of conservation of charges. And KVL is based upon law of conservation of energy. KVL is law of conservation of energy. KCL is law of conservation of charges. Next one. In the circuit shown, which of the following statement is not correct? Okay, not correct they are saying here. The circuit has super mesh. Yes, correct only now super mesh it has. Yes, now in the middle we have now super mesh is there. Super mesh we need to apply. Next, I2, the relation between I1 and I2. So this current, downward current, which we have this as I1. So this is upward current, which is equal to I2. Here you tell me now, here we have, this is I2 minus I1, which is equal to 6. That means I2 equal to 6 plus I1. Yes, this is correct, Olina. Next. And we will write the equation now. So what I will do here, we can write the equation in the outer loop. Outer loop, we can write the equation. So that is given as what, tell me now here, 6I1. Okay, 6I1 plus 10I2 plus 4I2 minus 20 equal to 0. So this value will come it as 6I1 plus 14I2, which is equal to 20. They given as minus 20 equal to 0. This only given, this is correct only. So now the D is wrong now. So D is wrong. Next one. In the circuit shown, the voltage across 4 ohm resistor can be expressed as the voltage across 4 ohm resistor is. Now, so what we can do, this voltage is V. Can you write the nodal equations? So if I say this is V value given, V value we can write now here, V minus E by 6 plus V by 4, and which is equal to leaving current only na 0. We need to get the V value. So this means we have taken the V common. Then we have 1 by 6 plus 1 by 4, and which is equal to what, tell me now? This is E by 6 minus I. That is V into what we have, tell me now? 4 plus 6, 10. 10 by, that is 6 into 4, and which is equal to what, tell me now? E by 6 minus I. Now if we cross multiply 10V, which is equal to what we'll get now here, 4E minus 24I. That means V is equal to 0.4E minus 2.4I. Yeah, so we'll get the relation like this now. Now tell me now, what is this equation? V is equal to 0.4E minus 2.4I. So option C. Next one. 3 resistances of R ohms, each are connected in delta. Its equivalent resistance in the star connection for phase is. All the resistors which are connected in delta form में 3 resistance, all are equal resistances. Now this is R, this is R, this is R. These are connected in delta form, they connected like this. So this is R1. So what is this R1 which will be given as? That is R into R by, that we have R plus R plus R. So this will come to be a R into R by 3R. So this will come to be a what, tell me now? This is R by 3. Yes, R by 3 each. Next, the RMS value of a alternating quantity having peak value 3 amperes is. And remember, RMS value, if this is, if we have a triangular wave is like this. If we have yes, so here this is a current T, and if I say this is I of T, So this value which is I naught and this value which is equal to minus I naught. We have like this. RMS value of a triangular wave, that is IRMS, which is equal to what you tell me now, I naught by root 3. Okay. So tell me now, I given 3 now, so that is 3 by root 3, which will come to be a what, tell me now? That is root 3 amperes. This is the option. Next one. The electric heater draws 10 amperes from 230 volts line. The resistance of the heater is so how much is current it is draws you, they given out 10 amperes. So that is resistance R is equal to, we can say now, V by I, that is voltage which is given as a 230 by current is given as a 10. So this will be equal to 23 ohms. Next one. A wire has resistance of 12 ohms. It is bent in the form of an equilateral triangle. The effective resistance between any two corners of the triangle is. A wire has a resistance of 12 ohms. The resistance is 12. It is bent in the form of an equilateral triangle. Total resistance of the wire, which is the 12, it is bent in the form of a triangle now here. So this means three sides are the equal sides. So that means each resistance will becomes what you tell me now. So this resistance which is a 4, this resistance is 4, this is also 4. Now this point is A and B. Now they ask him to find the resistance between any other two corners. Now you see this thing, how these two resistors now, these two resistances are in series. 4 and 4 will come to be what you tell me now, 8 ohms now. 8 and 4 are in parallel. So that means what I will get you tell me now, this is RAB, and which is equal to 8 parallel with 4 now. That is RAB, which will come to be what, tell me now, that is 8 by 3 ohms. Isn't it? So what's the option? You see this thing? Option A. Next one. An ideal current source has 0. Ideal current source, what it has? Ideal current source, internal resistance infinity. Okay. Ah, good one. So twisted here. So this is internal resistance of internal resistance internal resistance of ideal voltage source. Ideal voltage source is 0. Next one. Internal resistance of internal internal resistance of internal resistance of ideal ideal current source is ideal current source is infinity. Okay. Now the resistance is infinity. That's why conductance is zero. That means what we can say now, internal resistance of hmm, internal conductance, sorry, internal conductance of ideal what? Ideal current source is how much we can say? Ideal current source is zero. Okay. Next, three resistances of 1 ohm, 2 ohm, 3 ohms are connected in delta. These resistances are to be replaced by star connection as shown below. Delta to star. They asking the value of the highest resistance is. Okay, highest resistance के लिए numerator must be highest. Okay, so that means here will come the resistance na, and that means this resistance will be the highest maybe. Yes, this resistance will come the highest, isn't it? Okay, that they given us R3, so we can take it as R3, let us say. So you tell me now what is R3 value, which will be a 2 into 3 by 1 plus 2 plus 3 na. So that is 6 by 6. So that is R3 value will come to be a 1. We see the highest. Next one. In the given circuit below, voltage across the inductor is okay 220 volts and frequency given as a 100 by 2 pi. So this means if I convert now here in terms of resistance form, that is J omega value 100 omega into L is 1. So this is J100 now. We need the voltage across inductor which will be equal to VL. So yeah, you tell me now here VL which will be equal to, this is J100 by, so will come it as 100 plus J100 plus J100 into what we have, tell me now, 220. Check it. So that is VL which will be equal to J into 220 by 1 plus J will come na. So this is VL will come to be a J220 by, this magnitude is root 2 and phase angle we can say now 45. So that is VL which will come to be a, they are asking magnitude only. So this is 220 by root 2. Okay, at an angle 90. So this is 45. So this magnitude, if you see this value which will be equal to 220 by root 2. This is the answer, isn't it? Next, the equivalent inductance of the circuit given below at the terminals PQ is equivalent resistance, sorry, equivalent inductance. Yeah, you can tell me now how these two inductors are in series. How much this value? 4. 4 parallel will becomes as 2 na. Equivalent inductance between PQ, which will be equal to resistance calculation is same as a inductors calculation. So inductance and resistances are same only. So how much will come here? 2 Henry. So this is option. Next, for the circuit given below, the current through 1 ohm resistor will be What will be the current through 1 ohm resistor? They given the voltage which is given as 8 here. Okay, so this is AC now here. V is equal to, we can say now this voltage which will be given as VR, and this voltage we can say it as a VL inductor, that is given as VR plus inductor KDA, so that is J into VL na, since it is a phase angle, plus J na, so that is V which is equal to so this thing we can find its magnitude, we can find, so this is mod V which is equal to what, tell me now, square root of VR square plus VL square. And how much the V value given as 10, so 10 square equal to, that is VR plus VL value 8, that is 8 square. So that means VR equal to what, tell me now, 10 square minus 8 square. So that is VR which is equal VR square. VR square is 6 square. So that means VR which is equal to what, tell me now, 6 volts. They are asking current, they are asking to find. So that means how much this current is a, that is VR by 1, which will be equal to 6 amperes. Option C, isn't it? Next one. Admittance. Admittance is the reciprocal of impedance. Admittance is given as Y. Admittance, yes. Admittance is equal to 1 by impedance, no? Admittance is 1 by impedance. Y is equal to what element of 1 by Z. Next one. A capacitor C at time t is equal to 0 plus with initial charge Q naught will behave as. So at t is equal to 0 plus, that is the transient state now. T is equal to 0 plus, which is called as what element of transient state. In transient state, how the capacitor will behave? Capacitor will behave like a short circuit, but we have some charges there now. It will behave like a current source. So it will behave. So here, so transient state. In transient state, what happens now here? It will behave like a short circuit. In short circuit, we have voltage is there now something? Yes, so that means because of that voltage, it will behave like what we can say now. This is it will behave like a voltage circuit now. Capacitor having some charge. So one second. So if you draw the equivalent circuit now here, what the equivalent circuit of a capacitor? It always have a, so here series initial voltage. So this thing like this. And at t is equal to 0 will behave like a short circuit. A capacitor is shorted. So this is the equivalent circuit of a capacitor. Now basically capacitor is like this. Now it will behave like a short circuit having some charge is there. That means we can say V naught and this is C. Okay, so then this will be identically equal to what we can say. Tell me now here. It will behave like a only voltage is present and there is no capacitance, will behave like a short circuit. So this is V naught. So it is behave like a voltage source. Okay. Next one. They given the impedance Z1, Z2 given. They are asking to find Z1 by Z2 is. Tell me now Z1 by Z2 and which is equal to 20 angle 50 by 10 angle 30 degrees. So it will come to be what? Tell me now 2 angle 50 minus 30 which is equal to 20. So this is option D. Next one. The time constant of the network shown in the figure is time constant we need to get, and time constant के लिए we should after t greater than 0 we'll see now at t is equal to 0 switch is closed. Okay, now if I consider like this, and you can see now here time constant tau which will be equal to what we can say now, this is R equivalent into C equivalent. Let's find the R equivalent. R equivalent is how much we can say, and voltage is shorted, and this is R, this is 2R. With respect to capacitor we should find the R equivalent. So this is R equivalent, these two parallel now. So how much is value of R equivalent here, which will be equal to 2R by 3. Now from this tau value, so tau is equal to what? Tell me now 2R by 3 into C. So that is what? Tell me now 2RC by 3. So option D. So check it now, not option A. Option A 3R now. How the resistors now? R, 2R, these two are parallel, not in series, right? So it is 2R by 3 will come equivalent resistance. Next. An ideal voltage source will charge an ideal capacitor. How it will charge now? Instantaneously. If it is an ideal voltage source, it will charge the capacitor instantaneously. Ideal voltage source will charge an ideal capacitor instantaneously. Okay, so this is option C. Next, the current input is given as a 5 U of t is forced through a capacitor. The voltage Vc of t across the capacitor is. So means what they're saying here, here is a capacitor. This current which is I of t, and this is the capacitor. We need the voltage across the capacitor. What is the voltage across capacitor? Yes. Now we know the relation now here. I is equal to what? Tell me now. C into dv of t by dt. I is equal to C into dv by dt. From this V of t, which is equal to what? Tell me now. 1 by C integral of I of t into dt. Now you can tell me now. So that is V of t, which will come to be a 1 by C integral of U of t, that we can say now 0 to t now, that is 5 into dt. So we'll come it as what? Tell me now. This is, so this is 5 by c integral of dt. Yes, integral of dt is a t. So we'll come it as 5c by t. So that's by option C now. The nodal analysis is primarily based on the applications of. Nodal analysis is primarily based upon what you tell me now. In the nodal is a nodal, which is what we do here is a combination of KCL plus Ohm's law. Nodal is nothing but what you tell me now. Nodal analysis. There, what is nothing but this is a combination of KCL plus Ohm's law. By combination of KCL and Ohm's law is a nodal analysis. So here A and B. So that's why option D na. Nodal analysis is the combination of KCL and Ohm's law. Next one. The internal drop of a voltage source is. That means internal is independent of load current, depends on internal resistance, does not influence the terminal voltage, does affect the EMF of the source. So the depends on the internal resistance drop of the voltage source is, means what they're saying here. So we have taken this is now A and this is B, and this is the internal resistance if I call, and this is the some voltage V is there. Internal drop, that means the drop across the resistor R. It should be depends upon the internal resistance of the source. If the internal resistance is 0, then there is no drop now, ideal case, isn't it? So if I call this voltage across, this one is something Vx, and this Vx value depends upon what you tell me now. If I say this voltage, if I call the terminal voltage the VAB, and this VAB, which will be equal to what we can say now, this is V minus Vx. Okay, that Vx is equal to what we can say now, this is I into R. If this R value changes, Vx value changes, terminal voltage also changes. So we can say now it depends upon the internal resistance of the source now. Next one. A voltage waveform V of t is applied across 1H inductor for t greater than or equal to 0. Okay. Now, with initial current through it being 0, initial current is 0. The current through the inductor for t greater than 0 is given by. Okay. The voltage waveform V of t is given is applied across 1H inductor for t greater than or equal to 0, with initial current through it being 0. Mm. The current through inductor. So this is what is the voltage across inductor now here, basically V is equal to L into di by dt. V equal to L into di by dt, right? We need what you tell me now, current we need now here. This is I of t, which is equal to 1 by L integral of V of t into dt. Now let's get the V of t in I of t now here. And which will be equal to, this is 1 by 1 integral of 0 to t. This is, we have 12 t square into dt. Now you can see now here, this is I of t, which will be equal to 12 into what you tell me now, t cube by 3. Limits are, we have 0 to t. So that's why we can come to be I of t, which will be equal to 4t cube. Yes, this is the current. Okay. Next one. Two incandescent light bulbs of 40 watts and 60 watts rating are connected in series across the mains. Then what happens now? Mhm. So how these are connected? Series they connected. Mm. Across the mains, then the bulbs together, which will be glow brighter, which will glow darker. We need to identify this thing. Yeah, tell me now here. Power of the, yes, basically the resistance of the bulbs, which will be given as R is equal to what, tell me now? V square by P first thing. Okay. Now you can see now here P1 greater, sorry, P1 is less than P2. P1 is less than P2. That's why what happens now here, R1 greater than R2 first thing. Okay. Next, how these two connected, you see this thing. They're saying that these two are connected in series only. So we can treat the two bulbs as a resistors only. These two are connected in series only. Okay, for the mains. Now this is R1 and this is R2 and this is now V now, mains voltage. Now you tell me now R1 greater than, series connection current is same, and the power case, what I can say now, power equal to what we can say now here, current is same current is there, we can say I square into R we can write. So that means current is same, P proportional to R. Here whose resistance is more here, R1 greater than R2 here. So that's why P1 greater than P2. P1 means what, element of 40. So 40 watt bulbs glows brighter. The power across P1 is more. Next, given two coupled inductors L1, L2, their mutual inductance M satisfies. So the mutual inductance relation between them here, this is M. So that is, which is given as M, which is less than or equal to square root of L1 into L2. And this M, which is equal to what, tell me now? This is K into square root of L1, L2, where K is called as a coefficient of coupling. K is called as a coefficient of coupling. Yes, the K value, which is given as what, tell me now, M by, that is square root of L1 into L2. K value lies between 0 to 1. Yes, so this K value, so that means what I can say now, M by square root of L1 L2, which is less than or equal to 1. So that means obviously M less than or equal to square root of L1 L2. Right, so that's my option D. Right? Next one. Yes, as shown in the figure, the 1 ohm resistance is connected across a source that has a load line characteristics given as like this. Load line characteristics they given like this. Now, the current through the resistance is so connected across a source that has a load line V plus I is equal to 100. Then they are asking to find the current is. Tell me now here that is V plus I, which is equal to 100. Now here this current is I na, so that means V is equal to I. If I substitute now here, we need the current. So that is 2I, which is equal to 100. That means I is equal to how much we can say now here? 50 amperes. Next one. Consider the star network shown. The resistance between the terminals A and B with C open is given as 6. Between B and C with A open 11. Okay, between C and A with B open is 9. The values of RA, RB, RC is. So let's find out now here. They given this as between A and B when C is open. That means they given as RAB. They given this as RAB, which is equal to what you tell me now, RA plus RB. Yeah, that they given us what terminal 6. Between terminals B and C with A open, B and C, that means what terminal R, B, C, B and C with A, so C, A open, that means we can say now RB plus RC, and that is equal to 11. C and A, that is RCA with B open, that means RC. So from this we can say now this is RA plus RB plus RC, and which is equal to 13. So this is the sum of all the resistances. From that we need to get the things now. So if I call this is equation 1, let us say second equation, and this is the third equation, and this is a fourth equation. Equation 4 minus 1 if I do, then we'll get RC value will come now. So here equation 4 minus 1, equation 4 minus 1, then we'll get it as RC will come. RC value how much now? So 13 minus 6, which will be a 7, and equation 4 minus 2, then will come it as RB value, which will be a 2. Next equation 4 minus 3, then will come it as RA value, which will come to be a, what, tell me now? Here RA. Here RA will come. RA value 2. Next here RB will come, which is equal to 4. Yeah, check it now. RA is 2. RB, so option B na. Next one. Assuming ideal ammeters in the circuit shown below. the voltage VAB will be, VAB is, so we can see now this current, so this current is 1 ampere, so that means this is the positive, this is the negative now, so this is 2 volts. Now if we write the KVL in this loop, now tell me now KVL, so this is plus 2 minus 5 minus VAB equal to 0. So that's why VAB equal to what you tell me now here. Yeah, 2 minus 5, which is equal to minus 3 volts. Minus 3. Next. The wave shape of a current flowing through an inductor is shown. The wave shape of voltage is. The given current given, they ask him to find what, tell me now? Voltage flowing through inductor. So for inductor, voltage is given as V is equal to L into di by dt. Now I need to get this current, which is equal to what, tell me now? 1 by L integral of V into dt. So you can tell me now I is equal to integration of a ramp signal. Ramp signal will come, it is a parabolic signal will come. It will come to be integration of ramp now. Integration of a ramp signal. Oh, sorry, they given current given, yeah, sorry. They given the current given, we need the voltage. Okay, fine. So now the differentiation of a ramp is a step signal. The step signal you can see now option C. So here if I differentiate the ramp signal, so we'll get it as a ramp. If I differentiate now here, if I do the d by dt, will come it as whatever now step signal will come. Okay, so that's my option C. Next one. Two wires A and B of same material but different length have radius R2R respectively. The ratio of the specific resistance is same material but different length. Okay. Radius given, the ratio of the specific resistance. Specific resistance means rho. Resistivity. Hmm. Material is same, yeah. Material is same means specific resistance is same only, na? Ah, same material, yes, same. So it should be 1:1. Yeah. Specific resistance does not depends upon the physical dimensions. It will depends upon the material only. Yes. So you can make a note then. Specific resistance depends on material. Independent of physical dimensions. Independent of physical dimensions. So that's why this ratio is 1:1. Next one. A 20 microfarad capacitor is connected across an ideal voltage source. The current in the capacitor is ideal voltage source. Okay, so here the moment when we connect the capacitor to the voltage source, that is a DC. So what happens now at t is equal to 0 plus, immediately after connection, capacitor will behave like a short circuit. Then there is a very high current will flow. So the current in the capacitor is very high at first. After that, Exponential decays at steady state will become 0. Yes, correct. At t is equal to 0, that means t is equal to 0 plus, and capacitor will behave like what terminal short circuit. So then the current is very high. Current is very high. This is the transient state. Now at t tends to infinity, now this capacitor will behave like an open circuit, and finally the current will become what terminal 0. Okay. So option D. Next. In an RL series circuit, R is given, L is given, and supply frequency given. The magnitude of the impedance of the circuit is frequency. RL circuit na. So the impedance Z, which is equal to what you can see now, this is R plus J omega L. R value 20 plus J omega value 100 pi into inductance is 0.056. Yeah, tell me how much will come. So this is 100 pi into 0.056. Na? So this value will come 17. So this is 20 plus J 17.6 we can say. And its magnitude 20 square plus 17.6 square. This value 26.64. This is mod Z. That is 26.64. This is option B. Next. Given two coupled inductors L1, L2 having mutual inductance, the relationship among them must satisfy. Yes. What's the relation is a so this relation M, it is less than or equal to square root of L1, L2. This relation will satisfy. Even squaring also this thing. So that's why option A only. So basically the relation we have seen already previously, which is equal to K into square root of L1, L2. Next. If the length of a bar of a magnetic material is increased by 20% and cross-sectional area is decreased by 20%, the reluctance is reluctance. Like we have the resistance now. Resistance is given as what tell me now, R is equal to L by sigma A. And similar to that reluctance, that is called as the magnetic resistance is the reluctance. Magnetic resistance is a reluctance, which is given as L by, in place of sigma we have a mu will come. That's it. They given the length is increased by 20%, area of cross section decreased by 20%. So that means reluctance proportional to L by A na. So we can write it as R1 by R2, which is equal to what, tell me now, L1 by L2 into A2 by A1. So we can write now, if I say L1 is equal to 100, length is increased by 20% means so 120. And the area, so if I call this as 100, area decreased by 20%, that means which is equal to 80. So we can write this as R1 by R2. We can take a reciprocal, that is R2 by R1, which is equal to L2 by L1, that is 120 by 100, and A1 by A2, that is 100 by 80. So 100 will get cancelled, 0, 0, 4 twos and 4 threes, 3 by 2. So which we are getting it as how much now? This values, this value we are getting it as what? Tell me now. This is R2 by R1, and which is equal to 3 by 2. If I subtract 1, R2 by R1 minus 1, which is equal to 3 by 2 minus 1. Now will come it as R2 minus R1 by R1 into 100, which is equal to 1 by 2 into 100. So this value will come to be 50% now. Plus 50 means increased by 50%. Increased by plus now, that's why it is increased by 50%. Next one. Two coupled inductors L1 given, L2 given, having coefficient of coupling. They ask him to find the mutual inductance. Tell me now here. The mutual inductance M, which is equal to K into square root of L1 into L2. Now simplify, get it now here. So that is M is equal to K value 0.8 into square root of L1 is 0.2 into this is 0.8. So it should come to be what? Tell me now here. This is M is equal to 0.8 into square root of this is 16 into we can say 10 power minus 2. So that is M is equal to what? Tell me now. 0.8 into 4 into 10 power minus 1. Then will come to be a this is 32 into 10 power minus 2 we can write now. So from this which is equal to 0.32. Right. Yes, got this thing. So in this manner we can able to solve these problems. Done. Fine. Okay, yeah, that's it for today's class, and next class we'll meet in the next problems. Okay then.